NCERT Solutions, Class 10, Maths, Chapter 8, Exercise 8.3, Question 4. Prove the following identities where the angles involved are acute angles for which the expressions are defined. First problem. Cosecant theta minus cot theta whole square is equal to 1 minus cos theta by 1 plus cos theta. Let us take the LHS. LHS is equal to cosecant theta minus cot theta whole square. Cosecant theta can be written as 1 by sin theta minus cot theta can be written as cos theta by sin theta whole square. Take sin theta as LCM, and in the numerator we have 1 minus cos theta whole square, which is equal to 1 minus cos theta whole square by sin² theta. From the identity sin² theta plus cos² theta is equal to 1, we can write sin² theta is equal to 1 minus cos² theta. Which is of the form a square minus b square, where a is 1 and b is cos theta, which is equal to 1 minus cos theta of 1 plus cos theta. So we can substitute sin² theta with 1 minus cos theta of 1 plus cos theta, and the numerator can be written as, by expanding the power, 1 minus cos theta times 1 minus cos theta, and in the denominator we have 1 minus cos theta of 1 plus cos theta. We can cancel 1 minus cos theta from the numerator and denominator, which is equal to 1 minus cos theta by 1 plus cos theta, which is equal to RHS. Therefore, cosecant theta minus cot theta whole square is equal to 1 minus cos theta by 1 plus cos theta. Second problem. We have to prove cos A by 1 plus sin A plus 1 plus sin A by cos A is equal to 2 times secant A. Let us take the LHS. LHS is equal to cos A by 1 plus sin A plus 1 plus sin A by cos A. Take the LCM. LCM is 1 plus sin A times cos A. That we get in the denominator. And in the numerator we have cos A times cos A plus 1 plus sin A times 1 plus sin A. Which is equal to cos² A plus 1 plus sin A whole square by cos A of 1 plus sin A. Now let us expand the numerator. In the numerator we have 1 plus sin A whole square, which is of the form a plus b whole square, which is equal to 1 square plus 2 times 1 times sin A plus sin² A, which is equal to 1 plus 2 sin A plus sin² A. Now let us substitute this value in the place of 1 plus sin A whole square, which is equal to cos² A plus 1 plus 2 sin A plus sin² A by cos A of 1 plus sin A. In the numerator, cos² A plus sin² A can be written as 1. And already we have 1 plus 2 sin A divided by cos A of 1 plus sin A. Numerator becomes 2 plus 2 sin A, from which we can take 2 as common. Therefore 2 of 1 plus sin A by cos A of 1 plus sin A. Cancel 1 plus sin A from both numerator and denominator. We get 2 by cos A. 1 by cos A can be written as secant A, which is equal to 2 secant A, equal to RHS. Therefore, we have proved that cos A by 1 plus sin A plus 1 plus sin A by cos A is equal to 2 times secant A. Third problem. Prove that tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta is equal to 1 plus secant theta cosecant theta. Let us take the LHS. LHS is equal to tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta. Tan theta can be written as sin theta by cos theta, by 1 minus cot theta can be written as cos theta by sin theta plus cot theta can be written as cos theta by sin theta by 1 minus tan theta can be written as sin theta by cos theta. In the denominator, let us take sin theta as the LCM. So denominator becomes sin theta minus cos theta by sin theta. And in the second term, let us take cos theta as LCM. Cos theta minus sin theta by cos theta, which is equal to sin theta by cos theta times sin theta by sin theta minus cos theta plus cos theta by sin theta into cos theta by cos theta minus sin theta, which is equal to sin theta times sin theta is sin square theta by cos theta times sin theta minus cos theta plus cos theta times cos theta is cos square theta by sin theta of cos theta minus sin theta. In the second term, let us take minus out of cos theta minus sin theta, which becomes minus of sin theta minus cos theta, and the minus we can propagate it to the numerator. So we can write it as sin square theta by cos theta of sin theta minus cos theta minus cos square theta by sin theta of sin theta minus cos theta. Let us take LCM. LCM is sin theta cos theta of sin theta minus cos theta. And in the numerator it becomes sin square theta times sin theta minus cos square theta times cos theta. The numerator can be simplified as sin³ theta minus cos³ theta. It is in the form a cube minus b cube, which can be written as a minus b of a square plus ab plus b square, where a is equal to sin theta and b is equal to cos theta. Therefore, numerator can be written as sin theta minus cos theta of sin square theta plus sin theta cos theta plus cos square theta. From the numerator and denominator we can cancel sin theta minus cos theta. And also we can write sin square theta plus cos square theta as 1, which is equal to 1 plus sin theta cos theta divided by sin theta cos theta. Let us separate the terms. 1 divided by sin theta cos theta plus sin theta cos theta by sin theta cos theta. 1 by sin theta is cosecant theta and 1 by cos theta is secant theta, which is equal to 1 plus secant theta into cosecant theta equal to RHS. Therefore, we have proved that tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta is equal to 1 plus secant theta cosecant theta. Fourth problem. Prove that 1 plus secant A by secant A is equal to sin square A by 1 minus cos A. Let us take the LHS. LHS is equal to 1 plus secant A by secant A. Let us split the terms. 1 by secant A plus secant A by secant A, which is equal to 1 by secant A can be written as cos A plus 1 equal to 1 plus cos A. Now let us take the RHS term. Sin square A by 1 minus cos A. From the identity sin² a plus cos² a is equal to 1, we can write sin² a is equal to 1 minus cos² a. Which is equal to 1 minus cos a of 1 plus cos a. This is from a² minus b² is equal to a minus b of a plus b. Therefore, RHS becomes 1 minus cos a of 1 plus cos a by 1 minus cos a. We can cancel 1 minus cos a from both numerator and denominator, which becomes 1 plus cos a. We got LHS is equal to 1 plus cos a and RHS is equal to 1 plus cos a. So LHS is equal to RHS. Therefore, we have proved that 1 plus secant a by secant a is equal to sin² a by 1 minus cos a. Fifth problem. Prove that cos a minus sin a plus 1 by cos a plus sin a minus 1 is equal to cosecant a plus cot a. Let us take the LHS. LHS is equal to, rearrange terms in the numerator, 1 plus cos a minus sin a by cos a plus sin a minus 1. Multiply numerator and denominator by 1 plus cos a plus sin a. Let us rearrange the terms in the denominator. Cos a plus sin a plus 1. Numerator is of the form x minus y into x plus y, where x is 1 plus cos a and y is sin a. We can write it as x² minus y², which is 1 plus cos a whole square minus sin a whole square. And the denominator is of the form x minus y of x plus y, where x is cos a plus sin a and y is 1. We can write it as x² minus y², which is cos a plus sin a whole square minus 1 square. Now let us solve the numerator. One plus cos a whole square minus sin² a. Let us expand the first term. 1 plus cos a whole square, that is equal to 1 square plus 2 times 1 times cos a plus cos² a minus sin² a. 1 square is 1 minus sin² a. 1 minus sin² a can be written as cos² a. That is equal to 2 cos a plus cos² a. 1 minus sin² a is cos² a. That is equal to 2 cos a plus 2 times cos² a. Let us take 2 cos a as common and we get 2 cos a of 1 plus cos a. Now let us simplify the denominator. Denominator is cos a plus sin a whole square minus 1. Expand the first term. Cos a plus sin a whole square, that is equal to cos² a plus sin² a plus 2 times sin a cos a minus 1. Sin² a plus cos² a can be written as 1. One minus 1 is 0. That is equal to 2 sin a cos a. Therefore, denominator has reduced to 2 sin a cos a. Put the simplified numerator and denominator in the LHS. LHS is equal to 2 cos a of 1 plus cos a by 2 cos a sin a. We can cancel 2 cos a from both numerator and denominator. That is equal to 1 plus cos a by sin a. Let us write the terms separately. 1 by sin a plus cos a by sin a. 1 by sin A is cosecant A plus cos A by sin A is cot A. Cosecant A plus cot A is RHS. LHS is equal to RHS. Therefore, we have proved that cos A minus sin A plus 1 by cos A plus sin A minus 1 is equal to cosecant A plus cot A. Sixth problem. Prove that root over 1 plus sin A by 1 minus sin A is equal to secant A plus tan A. Let us take the LHS, which is equal to root over 1 plus sin A by 1 minus sin A. Inside the square root, let us multiply and divide by 1 plus sin A. That is equal to root over 1 plus sin A of 1 plus sin A by 1 minus sin A of 1 plus sin A, which is equal to root over 1 plus sin A whole square divided by, it is of the form A minus B into A plus B, which is equal to A square minus B square, where A is 1 and B is sin A. Therefore, we can write the denominator as 1 minus sin² A. That is equal to root over 1 plus sin A whole square by 1 minus sin² A is cos² A. That is equal to root over 1 plus sin A by cos A whole square. We can cancel square root and square. That is equal to 1 plus sin A by cos A. Now separate the terms. 1 by cos A plus sin A by cos A. That is equal to 1 by cos A is secant A plus sin A by cos A is tan A, which is equal to RHS. Therefore, we have proved that root over 1 plus sin A by 1 minus sin A is equal to secant A plus tan A. Prove that sin theta minus 2 sin³ theta by 2 cos³ theta minus cos theta is equal to tan theta. Let us take the LHS. LHS is equal to sin theta minus 2 sin³ theta divided by 2 cos³ theta minus cos theta. In the numerator, we can take sin theta as common. Sin theta of 1 minus 2 sin² theta. And in the denominator, we can take cos theta as common. Cos theta of 2 cos² theta minus 1. Now let us use the identity sin² theta plus cos² theta is equal to 1. That implies sin² theta is equal to 1 minus cos² theta. Let us substitute sin² theta is equal to 1 minus cos² theta in the numerator. LHS is equal to sin theta by cos theta of 1 minus 2 of, for sin² theta we substitute 1 minus cos² theta by 2 cos² theta minus 1. That is equal to sin theta by cos theta into 1 minus 2 into 1 minus 2 minus 2 into minus cos² theta plus 2 cos² theta divided by 2 cos² theta minus 1. That is equal to sin theta by cos theta into 2 cos² theta, 1 minus 2 is minus 1, divided by 2 cos² theta minus 1. 2 cos² theta minus 1 by 2 cos² theta minus 1 is equal to 1. LHS is equal to sin theta by cos theta into 1. Sin theta by cos theta can be written as tan theta, which is equal to RHS. LHS is equal to RHS. Therefore, we have proved that sin theta minus 2 sin³ theta divided by 2 cos³ theta minus cos theta is equal to tan theta. Prove that sin A plus cosecant A whole square plus cos A plus secant A whole square is equal to 7 plus tan² A plus cot² A. Let us take the LHS. LHS is equal to sin A plus cosecant A whole square plus cos A plus secant A whole square. Each term is of the form A plus B whole square. Let us expand these two terms. Sin A plus cosecant A whole square is equal to sin² A plus cosecant square A plus 2 times sin A cosecant A plus cos A plus secant A whole square is equal to cos² A plus secant square A plus 2 times cos A secant A. Let us bring sin² A and cos² A together. Sin² A plus cos² A plus cosecant square A plus 2 times sin A. Cosecant A can be written as 1 by sin A plus secant square A plus 2 times cos A times secant A can be written as 1 by cos A. Sin² A plus cos² A can be written as 1 plus cosecant square A plus, we can cancel sin A from numerator and denominator, which becomes plus 2. Then we have secant square A plus, we can cancel cos A from numerator and denominator, it becomes plus 2. Therefore LHS is equal to 1 plus cosecant square A plus 2 plus secant square A plus 2, that is equal to 1 plus 2 plus 2 is 5, 5 plus cosecant square A plus secant square A. Cosecant square A can be written as 1 plus cot² A and secant square A can be written as 1 plus tan² A. That implies LHS is equal to 5 plus 1 plus cot² A plus 1 plus tan² A. Let us add the constants and rearrange the terms. That implies LHS is equal to 5 plus 1 plus 1 is 7. 7 plus tan² A plus cot² A. That is equal to RHS. Therefore, we have proved that sin A plus cosecant A whole square plus cos A plus secant A whole square is equal to 7 plus tan² A plus cot² A. Ninth question. Prove that cosecant A minus sin A of secant A minus cos A is equal to 1 by tan A plus cot A. Let us take the LHS. LHS is equal to cosecant A minus sin A of secant A minus cos A. Cosecant A is equal to 1 by sin A minus sin A of secant A can be written as 1 by cos A minus cos A. Take the LCM. For the first two terms, sin A is the LCM, 1 minus sin A times sin A, that is sin² A of. For the last two terms, take cos A as the LCM. In the denominator we get cos A, in the numerator 1 minus cos A times cos A, cos² A. 1 minus sin² A can be written as cos² A by sin A into 1 minus cos² A can be written as sin² A divided by cos A. We can cancel one sin A from the numerator and denominator and one cos A from numerator and denominator, that is equal to sin A cos A. Now let us take the RHS. RHS is equal to 1 by tan A plus cot A. Tan A can be written as sin A by cos A plus cot A can be written as cos A by sin A. Let us take the LCM in the denominator, cos A sin A. Sin A times sin A plus cos A times cos A. That is equal to 1 divided by sin² A plus cos² A is 1 divided by sin A cos A. Let us rewrite the fraction. That is equal to sin A cos A. LHS is equal to RHS. Hence, we have proved that cosecant A minus sin A of secant A minus cos A is equal to 1 by tan A plus cot A. 10th problem. Prove that 1 plus tan² A by 1 plus cot² A is equal to 1 minus tan A by 1 minus cot A whole square. That is equal to tan² A. Now let us take the part 1, which is 1 plus tan² A by 1 plus cot² A. We know that 1 plus tan² A is equal to secant² A and 1 plus cot² A is equal to cosecant² A. Therefore, it becomes 1 plus tan² A is secant² A divided by 1 plus cot² A. We can write it as cosecant² A. That is equal to secant A by cosecant A whole square. Secant A can be written as 1 by cos A and cosecant A can be written as 1 by sin A. That is equal to sin A by cos A whole square. That is equal to tan A whole square. That is equal to tan² A. We have proved that 1 plus tan² A by 1 plus cot² A is equal to tan² A. Now let us do the second part. Part 2 is 1 minus tan A by 1 minus cot A whole square. That is equal to 1 minus tan A by 1 minus cot A can be written as 1 by tan A whole square. Let us take the LCM in the denominator. 1 times tan A minus 1 by tan A whole square. That is equal to 1 minus tan A by, let us take minus as common, minus of 1 minus tan A by tan A whole square. That is equal to we can cancel 1 minus tan A by 1 minus tan A. That is equal to minus tan A whole square. That is equal to tan² A. Therefore, we have proved that 1 minus tan A by 1 minus cot A whole square is equal to tan² A. From both part 1 and part 2, we have proved that 1 plus tan² A by 1 plus cot² A is equal to 1 minus tan A by 1 minus cot A whole square is equal to tan² A.